This is little Timmy. Timmy often finds himself in large facilities that are full of oranges and constructed stuck-together rooms. Now, Timmy really likes oranges. Not to eat, he just really wants to look at them. And I say power to him. But Timmy has a conundrum. He sees by ray casting. That means that when he wants to look at a spot, he shoots a ray towards it, and the ray tells him what he's looking at. This is a problem because ray casting takes him a lot of effort, and if he wants to find the closest orange he can look at, he just has to look at all of them until he knows for certain, which will quickly tire him out. So, how does Timmy find the closest orange that he has line of sight to? Well, Timmy could start by sorting all the oranges by distance and looking at the closest ones first. Sorting takes him some effort, but it saves more effort by allowing him to stop at the first one he sees. However, if he has line of sight to no oranges, he's back to having to look towards every single one. Because he also had to sort them first, this is even worse than doing nothing. He could also have a box around him and only look towards the oranges in that box. This saves a lot of effort as he doesn't have to look towards all the oranges outside the box. But what happens when he's in a long hallway with an orange at the end? If it's outside the box, he won't see it. The smaller the box is, the more oranges he'll miss, and the bigger it is, the more effort he has to spend. So we're going to have to try something more complex, and Timmy has an idea. He knows that the map is split into rooms, so he's going to ask each room to add itself to a group when it's created, and to add all the oranges inside of it to that group. If the room has an opening to the room above or to the left of it, it will instead add itself and its oranges to that group. If it has an opening to both, it will combine both groups into one. Now he can just ask the room he's in which group he's in, and then he can only look for the oranges in that group, allowing him to not waste effort on oranges he has no chance of seeing. Combine that with sorting the oranges by distance, and he can drastically improve performance. This is global. Every script can reference it. A lot of the variables and functions pertaining to groups are in this, since many things will need to access them. Room in which group is an array which contains rows of rooms, so room in which group 11.4 returns the group number of the room at y value 11 and x value 4. Objects in room is the same as room in which group, but instead of returning the group a room is in, it returns the objects in that room. Group takes in a group and returns an array of all the y and x values of the rooms in that group. This is where the rooms are created. White tiles correspond to, let me open up tile set. There it is. White tiles correspond to closed-off rooms that may or may not have doors. They don't have openings, so are added to their own group. These are the red tiles, like x equals 6, 7, 5, 4, so all the ones above 3. These are the red tiles in the tile set, and above. Red corresponds to hallway, and if they have openings to the left or top, they will check if they should add themselves to those rooms. In the tile set, a white pixel corresponds to a wall, and a black pixel corresponds to a door. Both can be put to the left or top of the room. So this is an empty hallway, and it would check both the left or the top. This wouldn't check either. This would just check the top. This would just check the left. This would just check the left, and so on. The code for this is pretty simple. Whether it should check the left or top is inputted as an offset into the tile in the dir array. So a vector 2 of -1, 0 means it checks the left. Vector 2, 0, -1 means it checks above it. If a room it checks is another hallway, it adds itself to that hallway's group. If it has to check 2 rooms and both are hallways, it loops through the first one's group and sets all the rooms in it to the group of the second, and then adds all their objects to the other group. This is some code I wrote to show how the group system works. When T is pressed, the player will teleport to the closest door. It starts by converting the pixel position of the player to the position of the room they're in. It plugs that into room in which group to find out what group it's in, then plugs that group into groups to find out what objects it should check. It loops to the objects, adds their distance from the player as a key to a dictionary, and the object itself as the object corresponding to that distance. It sorts the keys, then loops through the keys, raycasting to each one. When it sees one, it ends and teleports there. So seen by is a function in door, but it's also going to be in every other object that should or shouldn't be seen. Sorry. Func seen by. And so different objects will have like different ways that they should be seen. For example, doors are inside of a wall, and so they're going to need an offset, so that just looking straight at it, you might just see the wall, even if you can see the door, because the wall is there, it's inside the wall, and so this just like applies an offset. If it's a left door, then it applies a left or right offset if you're on that side. And if it's a top door, it applies an up or down offset to the raycast if you're on top or bottom. And then this is that code in action. It looks different because you can see I
made it visible in the background what the tile of a room is. So this is a hallway with a wall, so you can see it's white and red. This is a hallway with a door, so it's red and black. When I press T, I teleport to that door. And then if I go over here, the closest door is down there, so I teleport to that instead. And I'm here, I press T and teleport to it. I picked up the fireball. And then if I'm in here, where no door is visible, I press T, nothing happens. Well, okay, the fireball knocked me, so the door was visible. But yeah, now I'm in... Yeah. The game is still in development. It's a bit janky. But yeah, that's raycasting. Hooray.